Hello, everybody. We continue today our C hurdles tutorial, and hurdle number 2 is, of course, pointers. I know it's a big headache for the beginners. It's kind of unique feature. Only C and C++ have pointers, other languages don't. And today we are going to discuss pointers. I'm going to try to make it simpler. So basically, pointer, it's a new type of the variable. As you know, in C language, you got integer variables, character variables, double variables, but also you can create pointers to integers, pointers to characters, or pointers to double. So based on built-in type, you can create a new type. And in those variables, you keep the addresses of the other variables. For example, what you see in line number 6, I declare an integer variable and I put 99 as a value. Line 7, I created a pointer to int. And I don't know yet where it's going to point. So when you declare pointer, you don't know yet the address of the variable it points to, put null. So null is basically a pointer if it's not yet initialized. Otherwise, if you don't put null to your variable ptr, what happens is called sometimes stray pointer or dangling pointer. So it may have a random value, so it may point to a random area of the RAM, and your program may crash or may behave in a very unpredictable way. So you declare pointer by attaching asterisk to the int, character, or double. Is it possible to declare pointer like this? Yes, some programmers declare pointers like this, or even some programmers declare pointers like this. I still prefer the first. So all three, guys, all three declarations are correct. Compiler won't complain, but I still prefer this one because this is actually the variable type. So this is clear. When you attach asterisk to the type, you make it clear that's the new type of the variable. Okay, so line 8, I initiated my pointer and I saved the address of the variable x in my pointer. So you see, the first operator you have to learn when you learn pointers, it's ampersand. So ampersand operator takes the address of the variable and it is saved in a ptr variable. Then I print the value of my x variable. Line 9 going to print 99. But in line 10, I am printing the same number through the pointer. So this is called dereference operator or indirect or indirection operator. So what it does, it retrieves the value the pointer points to. So be careful, asterisk symbol is used in C in different meanings. So here you use asterisk as a part of declaration. Here you use asterisk as an operator, dereferencing operator. And if it's not clear, what I recommend to everybody, to all the beginners, try to draw the picture of the memory. So try to take a piece of paper, a pencil or a pen, and try to draw the memory diagram. So try to understand what happens by drawing. Okay, let's take a look. So I did, and I try to basically graphically explain what's happening in my program. So first line, I put 99 into X. So what you see here is two columns. Memory addresses on the left and memory values on the right. So for example, my X variable happened to be at 1012 memory address. As you know, integer variables usually 4 bytes. So from 1012 and up to 1015, 4 bytes, it's a variable 99. Next step, I create a pointer and I put address of the X into that pointer. Again, I draw the picture and let's say my pointer located at 20,208 memory address. And now you see that again pointer needs 4 bytes, and you see that at 20,208 address I have a value 1012. So basically you see what happened. You saved the first variable address to a second variable. So that's how ampersand operator works. You take in the address of the variable and you save it into another variable. In our case, X variable address coming to PTR variable. And finally, dereferencing operator, you have to also understand very well what dereferencing operator does. For example, I can dereference my variable PTR. What does it mean? Actually, dereferencing is a two-step procedure. So first of all, you retrieve the value of the PTR variable, which is 1012, and then you go into that address. So you go into the address 1012. After that, you retrieving the value at address 1012. And it is the same, it's 99. So basically, by dereferencing the pointer, you accessing the value of the variable your pointer is pointing to. So let's take a look. I'm gonna print both. I'm going to print value of the X in a simple way, and line 10 I'm printing the same value but through the pointer using dereferencing operator. So I expect in line 9 and 10 the same output. Also, in C, you may declare pointers to void. So those pointers don't point to certain types, they just point to the memory area. So it's like pure pointers. For example, I can ask system, give me 100 bytes of memory. So line 12 going to give you 100 bytes of dynamic memory, and this pointer cannot be dereferenced because it's a pointer to void. Of course, after I use that memory, I'm supposed to free that memory. So line 13 is doing cleaning. What makes the whole situation crazier is you can, technically speaking, declare pointer to pointer. So in line 15, I declare a variable pointer to pointer. It's assigned to the PTR address. And then I'm again printing 99, the value of the variable x, by dereferencing pointer twice. So first time when I dereference PTR to PTR, I got the address of my pointer. Second time when I dereference, I'm accessing the value of variable x. So technically speaking, all three printf statements, line 9, line 10, line 16, they should print the same number. Let's try it. So let me save the changes. Let me compile. And let's test if I'm correct. So that's what I thought. All three printf operators, they print the same number, the same value, 99. So again, let me recap. Pointers are unique features, unique C and C++ feature. You have to know how to declare pointers properly. I recommend the first way to declare pointers. It's more consistent, I think, but some programmers detach asterisk from the type. Some programmers attach asterisk to the pointer name. So guys, I don't do that because I think it's clearer if you declare pointers like I did. You have to know ampersand operation, what it does, how it works. I recommend drawing memory diagrams to understand ampersand. And you have to know dereference operator, asterisk operator. And again, memory diagrams may help you. So be careful in C, asterisk symbol has at least three different meanings. You use it to declare pointers, you use it to dereference pointers, and you use it to multiply numbers. So that's kind of confusing. You may declare pointers to void, and you may keep creating pointers to pointers. And unfortunately, pointers are everywhere. So they are used in arrays, in functions, in structures. So it is really essential stuff. And you have to master pointers before going to other C topics. Thank you very much for listening. Please watch my other videos. Put likes, subscribe for the channel, and all the best.